Okay, so here we have an example of finding surface area. This problem says find the surface area under the function, under the relation. This ends up being a plane, but under the relation 3x plus 2y plus z equals 6. And then we're looking at in the first octant. So first octant means my x, y, and z, those values are all positive. So I'm going to go ahead and sketch this first, just so we can see what we're looking at. That means I'm only interested in values that would be here in that first octant, so positive x, y, and z values. To sketch this, what I'm going to do is I'm going to look at intercepts first. I'll plug in a 0 for y and z, so that tells me my x-intercept is 2. I'm going to plug in a 0 for x and z. That tells me my y-intercept is 3. And I'll plug in a 0 for x and y. So that tells me that my y-intercept, or my z-intercept is 6. So what that means the question's asking us to find is the surface area. Oop, that missed. The surface area of this kind of triangular surface. That triangle that looks like it's leaning up against that corner there, okay? So with any, we're gonna use that double integral formula. So here, the double integral over the region of the square root of 1 plus partial x plus partial y dA. So reminding when I do a double integral like this, the first thing I need to do is take care of my region, which means I'm going to decide, do I want to write this in terms of rectangular coordinates or polar coordinates? Let's look at the region first and see what we decide. This region is really just this part of the graph down here that's in the xy plane, right? It's going to be weird to look at it here because my x and my y, the orientation switched on us. So let's write it down here. My x-intercept was 2. My y-intercept is 3. So this is our region R that we're trying to integrate over. I'm going to go ahead and write this. I'm going to say that we should stay in rectangular coordinates. Since I don't have something I can easily write as a polar representation. I don't have a unit disk or circle or something that I could switch the x squared, y squared with an r squared. So I'm going to take this as type 1. Type 1 means that my x values are constants. And that means that my y value is going to be bounded by some value, some function of x. So here, my y values are going to go from 0 up to that relationship. So my y values go from 0 to the equation of this line. So let's see. That's the relationship that we're given. I can just set z equal to 0. That allows me to write this. So that means that 2y equals minus 3x plus 6. So y is minus 3 over 2, x plus 3. So that gives me the bound for my y value. So that tells me I can write this. I can do the double integral. My x values go from 0 to 2. My y values go from 0 to negative 3 over 2x plus 3. So now the next thing I need to do is let's fill in. So I need to start filling in these values. So I need to have my partial derivative with respect to x and my partial derivative with respect to y. Right now I have a function of x, y, z. So I need to rewrite it so it's z equals. So if I take this, I'll get z equals 6 minus 3x minus 2y. So that means that my partial with respect to x is going to be, that's a constant. That gives me minus 3. And then that is considered a constant when I'm thinking about x. My partial with respect to y, that's a constant. That has no y, so it's a constant. That gives me a negative 2. So I can plug into my formula, 1 plus negative 3 squared plus negative 2 squared. Then I'll do dy dx. I need to put that dy first because my y value is bounded by x. So I need to integrate this first so that then when I'm done, my last integral only has numerical values as my limits of integration. This is 1 plus 9 plus 4, so that's square root of 14. So let's say the integral from 0 to 2, integral from 0 to negative 3 over 2x plus 3, the square root of 14 dy dx. So my antiderivative here is just going to be square root of 14 times y. When I evaluate that, the 0 goes away. So I'm just left with square root of 14 times this. So I left the integral from 0 to 2, square root of 14 times minus 3 over 2x plus 3 dx. So what I'm going to do is I'm going to take this, again, square root of 14 is just a constant. So if that comes to the outside, this antiderivative, this antiderivative is going to become negative 3 over 4, negative 3/4 x squared plus 3x. I'm going to evaluate this from 0 to 2. The same thing at the last one when I did y. When I plug a 0 in, everything has an x in it, so the 0 is going to cancel everything out. So I don't really need to worry about this one so much. Right? So all I really care about is what happens when I plug in 2. So here, this is going to be negative 3/4 times 4. That gives me negative 3 plus 6. Negative 3 plus 6 is 3. 3 times square root of 14. So that tells me the surface area of this triangular surface that's given to us. This portion of the plane has a surface area of 3 square root 14. That's one example of how to do surface area. A little easier because our the two partials that we had were just constants, right? So we didn't really have to worry about integrating anything very difficult because the formula simplified very easily. Check back in, we'll have another example that's a little more difficult to talk about integration techniques and practicing that. So we'll see you guys soon.